Welcome. This is a video on the directions on how to complete the projectile motion simulation activity planner. So I'm going to be going over this in class, but if by chance you need more help or if you are absent or you just want to review something, you can watch this video. So this is going to be a STEM engineering challenge, and our learning target is we as a team, and you're going to have the option to pick your teams. You can also work by yourself if you want, but we as a team will design a method of using the projectile motion simulator to hit a target at a specified distance. So the materials your group's going to need is you're going to need your Chromebooks. You'll need it every day during this unit. There's already one time when we started working on the IXL that not everybody had their Chromebooks, and all of a sudden I didn't have enough to lend out because a bunch of people didn't bring their Chromebooks or they didn't have them charged. You're going to need a data spreadsheet, and that can be found in Google Classroom, and you're going to need the planner, the activity sheet that can be found in Google Classroom as well. So, the background information. Several factors affect how far a projectile will travel. The three most important variables are the launch angle, the platform height, and the magnitude of the initial force. In other words, the initial speed that sets the object into motion. In order to determine how these variables affect the projectile's horizontal distance, experiments need to be designed to test each variable independently. This is done by making observations under controlled conditions where only one variable at a time is changed. Controlled experiments make it possible to separate or isolate the factors that are reasonable or responsible for a given observation in a complex series of events. In this activity, you will examine how launch angle, platform height, and the magnitude of the initial force affect the horizontal distance traveled by a projectile. So you're going to be using a simulator, and you are going to be varying or changing the platform height, the magnitude, and the launch angle to get various launch distances. Now, your team is going to use the projectile motion simulator to collect this data and to make all those changes with the platform height, the initial speed, and the angle. You are going to have access to a data sheet. This data sheet should be in an easy to use format that should be shared with your team members and myself. Your team, on the day of the test, your team will then use that data to hit a target of an unspecified distance between 20 and 90 meters. So what I'm going to do on test day is you don't know exactly what distance you're going to get. And so, for example, if all of a sudden I say, well, you got to hit 50 meters. What you have to be able to do is you have to be able to go back into your data, look at all the data, find a 50 meter, and know exactly how to set the platform height, the initial speed, and the angle. And if you have all the data, and if you have really good data that's easy to use, that you can easily track and find this, the test really should be easy for you. The problem is if you don't have good data, you don't have a good way to organize your data, then the test could be a little bit more complicated. So you will not find out the exact distance until the day of the test, and your team will be graded on your ability to hit the target. So what we're going to be doing is we're going to be using the engineering design process. So before we start everything, we're going to be going through these 6 steps to design our experiment. So the engineering design process can be used to solve a wide range of problems. The diagram below, it's actually off to the side here, shows one version of the process. In this version, there are 6 steps, each shown in a different circle. Often an individual or a team will move clockwise through the steps in the diagram, beginning with the step at the top, which is identify the problem. So the diagram also has lines that connect each step to every other step in the process. These lines represent the many possible alternate paths. An individual or team may repeat or even skip steps, depending on the problems being solved or the problem being solved. Every engineering design challenge is unique, and so is the path to finding a solution. So when you guys were working on the IXLs in class, one of the reasons why I had you work on C1, C2, C3, C4 was because they went through all these different steps. So when you start going through the process, when you start designing your plan, you already know the steps. So the plan, I'll have groups be done with the plan in about 15, 20 minutes. It doesn't take very long at all. But if you don't know all the steps of the plan, then it's going to take you a little bit longer to do. So the last thing I'm going to do in this video is I'm just going to let you know that, again, you're going to be able to pick your groups. Now choose your partners wisely because you guys are going to get the same grade. So if there's someone in your group that you don't think you can work well with, you may not want to have them in your group. You may want to go join a different group. So here is the rubric that I'm going to be using that goes through the different parts of the engineering design process that I'm going to be grading you on. So I just want to make sure that you're aware of this. That way you know that you are being graded. So this will end part one. Part two, we'll be going through the engineering design plan that you're going to have to complete.